Hi there, welcome back. In this video, we are going to be looking at a formula that goes with a right triangle. Okay, so I want you to find memory pieces 45 and 46. They look like this. Let me check those numbers. Yes, 45 and 46. Go ahead and cut those out. I would not paste this one down just yet. Let me just take it out of the frame here for now. But go ahead and paste down this one, number 45. You can stick it down about right there. And we're going to give this page a title, as we always do. We're going to call this the Pythagorean theorem. Now that's a mouthful, I know. Don't panic. It's Pythagorean theorem. Pythagoras was a Greek man, I believe he was Greek, who lived a long time ago. And he came up with this formula that goes with right triangles. So Pythagorean means that it belonged to Pythagoras, and theorem is just a formula, a math theory. So the Pythagorean theorem is this: a squared plus b squared equals c squared. Okay, and don't worry about that just yet. We'll get there. But let me set up a story for you. Let's look at this picture and let's put a story to it to help us get an idea of what we're doing here. So I want you to draw a point up here at this vertex, and a point at this vertex, and a point at this vertex. And I want you to call this one point H, or let's just write the word house. Okay, and down here, let's write W, or the word work. So when I get up in the morning and I start out the door to work, I have to make a decision how I'm going to drive there. There are two ways, according to this diagram, that I could go. When I leave my house, I could travel south. And let's go ahead and put some numbers to this. So I'm going to travel south 4 miles. Make a right turn and travel 3 more miles this way. So that's one way that I could get from home to work. How many miles have I traveled? 7. And you can see the other way. I could just go from here to here in a straight line. That's as the crow flies. You may have heard that expression. A bird in the sky doesn't have to worry about traffic and stop signs and red lights. It's going to fly from point to point as the crow flies. That distance in my picture is 5 miles. So if I go as the crow flies, I can save myself 2 miles each way, each trip. That's Pythagoras' idea. And here's what Pythagoras said. And I want you to write this down. I'm going to use red because it's important. The shortest distance between 2 points is a straight line. So Pythagoras got to thinking about that. He said, you know, the shortest distance in this picture is as the crow flies. It's in a straight line between those two places. But he needed a formula that would prove that. He needed a theorem that would make that be true or show that it's true. He needed the proof. And so he came up with this theorem, this formula, and here it is. Here's Pythagoras' theorem. A squared plus B squared equals C squared. Now, when we talked about the anatomy of triangles, remember I told you that this side is called hypotenuse. Let me change colors. I'm getting a lot of info in here. This is hypotenuse. It's across from the right angle. And I told you that this side is always C. And that this is a leg. And this is a leg. And that these are A and B. You can interchange those. I like B on the bottom because that's the base. But be aware that those can flip-flop. But C cannot. So let's see if Pythagoras' theorem holds true. All right, so I'm going to put in a place for my A, a place for my B, and a place for my C. A squared. So A is the 4. That's one of the legs. So 4 is a leg, 3 is a leg, and 5 is hypotenuse. So let's see if mathematically this proves to be true. 4 times 4 is 16. 3 times 3 is 9. And 5 times 5 is 25. 16 plus 9 is 25. And that equals 25 on the hypotenuse side. That is proven true. Pythagoras' theorem will always work on one condition. There must be something true for this to work. Something must be true. You must have a right angle. It cannot be anything more or less than 90 degrees for this to work. But if you have a right angle, this theorem will always work for you. Okay, let me show you this other version of this picture. So let's bring this one in. This is saying exactly the same thing. Now they have flip-flopped A and B. And that's one reason I chose this. I want you to see that it still works. They've made they've turned the triangle over on its side, essentially. But when I say 3 to the second power, 3 squared, I get 9. When I say 4 to the second power, I get 16. And then when I say 5 to the second power, I get 25. And using those graph boxes, those pieces with the squares, you can see that this theorem proves true visually as well. That the 25, the 5 squared, is equivalent to the 3 squared and the 16 squared. I never really understood Pythagoras' theorem until I saw this picture. Because this triangle in here is like the one that you and I just drew up there. That is proof of the Pythagorean theorem. Now, I want to show you another example or two of the Pythagorean theorem. And I'm going to squeeze it in here. I don't normally like squeezing in, but I'm not going to start a new notebook page for this. So if you want to section off, you can. I'm going to section off. So all of this goes together. And let's do another right triangle. Let's just make one up. So we'll put a problem right in here. And let me draw you one. This time I'm going to let it open to the left. There's no such thing as a left triangle, but it can certainly be turned that way. So here's the right angle. Go ahead and draw this with me, please. And I can already tell you that this is a leg because it's hooked to the right angle. This is a leg, and this is the hypotenuse. This will be side C, and this can be A or B. I like it to be B. I like this one to be A, but you can flip-flop those. So here are some numbers. Let's say that leg A is, let me think, 10 feet. Leg B is 12 feet. And we want to know, as the crow flies, what is this hypotenuse? So Pythagoras tells me that if you have a right angle in your picture, you can use my theorem. So I'm going to do that. I'm going to say a squared plus b squared equals c squared. That's what Pythagoras told us. And we proved it right up above there. We know it works. So let's make a place for A. Let's make a place for B. And let's make a place for C. So A, I'm using the 10, and B, the 12. You put the legs in these two, and you can flip-flop them. Because you're building up, it won't matter. But I don't know C. I'm going to put C in there because I just don't know what C is. And so I'm going to take away my parentheses. I don't even know what C is, so I don't need parentheses there. So here we go. 10 times 10, that's 100. 12 times 12 is 144. And those get added to give me C squared. So 100 plus 144, that's 244. And that is C squared. Now stop and think. I'm not trying to tell you that this dimension, C, that's the hypotenuse. Let me try that again. Hypotenuse is C. That's not 244 feet. There's no way. If leg B is 12, and leg A is 10, there is no earthly way that C could be 244 feet. But that's not what this is saying to me. This is saying that C squared is 244 feet. So we have to take the square root of both sides. The square root of C squared is plain old C. That's what we want. So on my calculator, I need to find the square root of 244. Now, it's not going to be a nice, neat number, and that's okay. I chose that on purpose because I want you to know that it won't always be a nice, neat number. I'm trying to get my calculator to start on my cell phone, and it's not cooperating. I'm sorry, guys. I may have to come back and clip this in for you. Here we go. I've got to get a new cell phone. This thing is a piece of junk, but it has been a good piece of junk. Okay, so to do this, and I'll show you how to do it on the Casio. Great. Mine will not do square root. Isn't that wonderful? Let me go to the internet. I should know better than to come to math class without a calculator. Shame on me. All right, while this is loading, let me give you the steps for your Casio. Actually, it just loaded for me. It is 15.62 and a bunch of other junk. So I'm just going to say that it is about 15.6. And I'm using that squiggly equals to show you that it is about 15.6. On the Casio, here are the keystrokes. And I always put these in boxes for you so you can tell that they're calculator steps. Okay, we are going to do shift 244, shift 244. Oh, I'm sorry. No. We're going to do all clear 244. I'm sorry. Then shift and X2. If you notice, over the X2 button is the square root key. That's what we're after. It's not X squared, it's the button above it. It's right here that I'm trying to get to. That's why you shift to get to that one. And then, of course, you need to always press equals. I don't think you absolutely have to on that one, but I would get in the habit of that. And it's going to give you something ugly. Let me just go ahead and give you what mine did. 204994. So the hypotenuse on this thing is about 15.6 feet. Okay. So in the proofs, we knew the answer. We knew the numbers. We just had to prove that it fits. Here you actually had to find the hypotenuse. Okay, here is one more thing that I want to show you. This is a very practical example of this skill. So to do this one, I want you to draw a box. Let's draw right here. And let's say that I go to Walmart or to one of the stores. I'm looking for a new television. Okay? And I know that the television I'm looking at is, let me think, guys, so that I can set this up correctly. We're going to say that it is, actually, let's do it this way. I want you to put in a line right here. And we're going to say that this line right there is 70 inches. This is a 70-inch television. It is a big television. It's like a theater-sized television. Okay? I need to know if this television is going to fit in the space I have at home. So I need to know this dimension, and I need to know this dimension. So at first glance, this doesn't look like Pythagorean theorem. You may be thinking, what does this have to do with anything that she's just shown me? But I want you to let your mind wander just a little bit to the inside of this box. Do you see right angles in there? Sure I do. I see, here's one, and here's one, and here's one, and here's one. So we are definitely dealing with right angles. All right. So let's pick one of those. I think I'm going to pick this one because this is the one that I've labeled. So there's a right angle. And I'm going to just imagine that this line disappears. We'll make it imaginary. Look at what you've got. This is one of Pythagoras's wonderful right triangles. Okay. Now I know this is a 70-inch TV. That means the diagonal on this thing is 70 inches. What I'm looking for will be the legs of the triangle. So 70 is the hypotenuse. That is side C. And I happen to notice, or maybe that we're able to measure, that this one is 40 inches. Okay. So let's figure out how tall this TV is going to be. So I'm going to use Pythagoras's lovely theorem. And I'm going to plug in what I know. I know C is 70. I like this to be A. I don't know A, but I do know B is 40. So let's simplify. Use your calculator. 40 times 40 is 1600. 70 times 70 is 4900. And then you have a squared and a plus sign and an equal sign. You also have an algebra formula here, because let me draw the power t and I'll show you what I mean. I should have drawn it above. Because look at this, the a is the variable, so this is the variable side. This is the constant side. So what needs to move? What's on the wrong team? It is that 1600. So we're going to move the 1600 over here to the constants team. And we always cancel. So we're left with a squared. And then on this side, 3300. Now remember, I'm not telling you that I need 3,300 inches to put this TV in. This is not A, it's A squared. So how do I find plane A? Do you know what to do? You do. You take the square root of 3,300. You have to do it to both sides. So we're going to take the square root of A squared, that's an A, and then the square root of 3,300. And I'm trying to calculate that on my cell phone again. Oh, it's wanting to do all kinds of crazy stuff to me. 3,300, I just want it to do equals. Again, guys, I should have brought my calculator to the math class. That is not okay. So I'm going to have to get this on my cell phone. Let me put in the keystrokes for you so that you can do this on your calculator if you have the Casio. Actually, I'm going to put the keystroke buttons and see if you know what goes in there while I work with getting the square root of 3,300. You may know it in your head, but I don't. Here we go. 57.4456265. So I'm going to say about You want to call it 57 or 58. I'm going to say about 57 because that's how it rounds. If I were putting this in my house, though, I would definitely round up to 58. But since the rounding rule tells us 57. Okay, to do this on the Casio, you press all clear, 3300, shift x squared, because you don't want x squared, you want the thing above it, and then equals. And you should get the same thing I did. So there is a real-life practical example of how Pythagorean theorem is used in everyday life. This is a very handy concept. If you work in construction and you need to square things up evenly, you need to know Pythagorean theorem. So I know this one's a little complicated. If you have questions, please contact your instructor. There's more practice available. There's more practice on the internet. But this is one that you see often on math tests, so I wanted to make sure I showed it to you. I will see you soon. I hope you have a great day. Bye-bye.